Hi guys, today we're going to be talking about 6.1, which is identifying and representing functions. The TEK that we're going to be looking at is identify functions using sets of ordered pairs, tables, mappings, and graphs. Our essential question here is how can you identify and represent functions? Okay, so from the TEK, what's really new to us are mappings, which we're going to talk about. I'll refer to them as mapping diagrams. Okay, so keep that in mind. So what we know from our prior knowledge is that a relationship is when two things go together. Okay, in math, a relation means set of ordered pairs. The x and the y go together. For instance, we have 6, 2, 0, 1, 2, 3. Okay, notice that I put them in braces because that's going to represent our function. Okay, an ordered pair, remember, is x, y in parentheses. We have our x value and then we have our y value. The x value is actually in math called an input, okay, which just represents our x values. The y is our output, which represents our y values. So now we have our x and our y, but we also have our input and our output. Input is our x, output is our y. So what I want you to do is circle each input value and underline each output value. So for instance, this first one, again, remember input are my x values, so that's always the first value inside of our parentheses. So I'm going to circle the 1, circle the 2, circle the 3, okay, and then I'm going to underline the output, which is our y values. So in the first ordered pair, 1 is our output, 3 is our output, and 5 is our output. Go ahead and take a second to do number 2. Again, I want you to circle the input value and underline each output value. Okay, when you're done, it should look something like this. Our input values are 6, 5, and 4, and our output values are 2, 3, and 8. Okay, remember input represents our x values, output represents our y values. Okay, so we're talking about functions here. The TEK says identify functions. So we need to talk about what a function is. Okay, a relation is a function. So our relationship between our x and our y is a function when each input value, which is our x values, pairs up with exactly one output value, which is our y. So in relation, an x value has to have only one y value. You have to remember this. An x value has only one y value. Okay, x's can't have different y's, or that's not a function. And we're going to look at that in all of our separate ways that the TEK is asking us. Okay, but an x value has only one y value. Okay, now there's 4 ways of representing a function or relation, and they're actually listed in the TEK. First way is an xy table. Second way is an ordered pair. Third way is a graph. And fourth way is a mapping diagram. So the first 3 are really familiar to us because we know how to identify functions and linear relationships from an xy table, ordered pairs, and graphs. Mapping diagram is a little bit new for us, but it's really easy and you guys will be professionals at this. Okay, so if we're going to look at all 4 ways now. Okay, the first way we're going to look at is our xy table. Okay, I need to identify if it is a function or not. So again, remember, a function is when the x values have one y value. So if I look to the first box, okay, my input are my x's, so I have 2, 3, 4, and 5, and my output, which are my y values, are 3, 6, 9, and 2. Okay, I'm asking myself, is this a function? Do the x values only have one y value? And if I look, 2 matches up with 3, 3 matches up with 6, 4 matches up with 9, 5 matches up with 2. So, this is a function because all the x values, which is our inputs, have one y value. They don't share any. So this would make a function. Okay, if we look at this next one, okay, our inputs are now 1, 2, 0, and 1, which these are the same exact inputs, which is our x's. Okay, and notice, do they have the same y value? No, they don't. 1 is matched up with 4 here, and 1 is matched up with 7. So this would represent a table that is not a function because the 1, which is our input, is paired up with 2 outputs. Okay, it's paired up with 4 and it's paired up with 7. That does not match up with our definition of a function, that the x value has 1 output. Okay, this x value has 4. That same x value has a 7. So they're 2 totally different outputs, which means this is not a function. Okay, now let's look at a graph. Okay, notice these points on a graph. You can see it a little bit better if I color them in. Okay, all of these points, okay, I need to determine if the x values have 1 y value. So if I actually label these points, this is over 1 up 0, so this is 1 comma 0. This next one is 3 comma 2. This next one is 5 comma 3. And this one at the top is 4 comma 6. So I could label them and list them all out, which I will do. Okay, however, I can just look at the x values. I have a 1, 3, 4, and 5. They're all different x values, and they are matched up with the output values of 0, 2, 3, and 6. Okay, I don't hear any repeating ones, and I know that the x values don't share the same y value. So in that case, I know this is a function because all the x values have 1 y value. So this would create a function. Now if we look at this other graph, now notice these aren't graphs that we've seen before. Some of you may. Okay, this is actually called a scatter plot. Okay, where they're just points, and we could connect the dots if we wanted to, but it would represent a relationship between the x and the y axis and what they represent. So if I'm looking at these points now, again, I'm going to figure out what the input and the output, or the x and y value, is for each of these points. So this first one is 2 comma 3. This one is 3 comma 4. This one is 3 comma 5. And this one that's the farthest to the right is 5 comma 6. Now, if I notice my x values, or my inputs, I have 2, 3, 3, and 5. I already see a big problem here. I see that I have 2 input values that are the same, which are 3. And I know that the x value has to have only 1 y. However, this 3 is matched up with a 5, and this 3 is matched up with a 4. Therefore, this is not a function. The x value of 3 has 2 y values, or 2 outputs, which are 4 and 5. So this is not a function. Okay, another way that's really cool with the graph and how to identify if it's a function or not, which you guys will look at a little bit tomorrow during the activity, but it's called the vertical line test. Okay, a vertical line, remember, goes up and down. Okay, so if I draw a vertical line through every single one of these points, okay, there should only be 1 point on the line if it's a function. So if I draw a line here, there's only 1 point on that line. If I draw a vertical line here, how many points are actually on that line? There's 2 points, which means they share that same x value. So that would be considered not a function. If I look at the same graph and do the vertical line on this one, okay, vertical line, there's 1 point on that line. Vertical line, 1 point. 1 point, 1 point. Therefore, this graph would represent a function because the x value has only 1 y value. So the vertical line test is another way of identifying if a graph is a function or not. Okay, the third way of identifying if it's a function or not is our coordinates, okay, or our ordered pairs, or our list. So I'm looking at my inputs and my outputs, which you guys already identified prior to getting to this table. Okay, my inputs, which are my x values, are 4, 3, 2, and 1, and they're matched up with 3, 6, 2, and 0. I notice that all the x values have only 1 y value, so this is a function. All the x values have only 1 y value. Okay, if I look at this next one, 5, 3, so my input is 5, output is 3, input is 5, output is 6. Right away, There's the same exact x value, but they have two different y values. So this is not a function because this x value of 5 is paired with two different y values. It's paired with both the 3 and the 6. So I know this is not a function. These coordinates or ordered pairs do not form a function. Okay, and our fourth way, which is newer to us, is the mapping diagram. Notice the mapping diagram has two sections. We have the left section is the input, which represents our x values, and the right section is our output, which represents our y values. So if I look at this first one, these represent coordinates. Okay, it's just another way of representing. So this point right here would be considered 2, 5. This next one would be 1, 1, and this next one would be 3, 1. So the mapping diagram is just a different way of looking at how we could write our ordered pairs. So looking at these points now, I notice that all my x's are different, okay, and it's sharing a y value. Is that okay? Okay, if I refer back to my definition, we want x value has only one y value. So do the x values have one y value? Yes, it does. Okay, so that means that this is a function because all the x values have one y value. Okay, now if we look at the second option, our input are our x values, output is our y. Okay, so off to the side I have 3, 5. That's my first point. 2, 4. I have 1, 1, and 1, 3. Okay, so I'm looking to see if the x values have one y value. Okay, notice the x value of 1 has two different y values. They have the 1 and they have the 3. So this is not possible. This is not a function because the x value of 1 is paired with two different y values, and those y values are 1 and 3. Okay, so those are 4 ways of identifying if it's a function or not, and you're going to have to be able to go back and forth and determine if it's a function or not from these 4 ways. So flip your paper over on the back. Okay, I want you to practice a little bit more by telling me if it is a function or not, and explain how you know that. So sort of what we just did, but now you're going to actually see some examples. So, I wrote at the very top, and I would love for you to do that too, just as a reminder that the x values have to have one y value. Okay, that's just, you have to remember that. That's something you need to memorize. The x value has one y value. Okay, so first we're going to look at the coordinates or the list on how STAR could possibly ask you, or just so you identify it. Looking at this first coordinate or list, okay, I need to identify if it's a function or not. So I need to look at my x values and see if all the x values have one y value. So my x values are 1, 3, 6, and 9. My y values are 5, 7, 5, and 8. So do all the x values have a y value? And yes, they do. The 5s are the same, however, the x value has that one y value, so that's okay. So this would be considered a function, okay, because all the x values have one y value. Okay, go ahead and do that second example, and when you're finished, push play again. Once you're done, you should have noticed that these coordinates or these ordered pairs do not create a function because the x value of 1, which is our input, share that 2 and the 8. These x values have different y values. Okay, so that cannot be a function. Okay, looking at the next thing, our mapping diagram. Remember, the x's or the inputs are always on the left side. The outputs are on the right side. So these points would really be 5, 3, 4, 3, 3, 3, 2, 3, and 1, 3. Okay, I'm trying to identify if this is a function or not. So I'm looking at, do the x values have one y value to go to? Do all these x values? Yes, they do. The x or the y value is 3. Okay, so this is considered a function. All the x values have the one y value. Okay, go ahead and do this second example by yourself. Pause the video, and when you're done, push play. Okay, so I'm looking at this next one. Okay, my inputs are 2, 1, and 3, and my outputs are 5, 1, and 2. Notice how many arrows I have. I have one arrow, which represents 2, 5. I have this other straight arrow that goes from 1 to 1, which is my second point. And then I also have this arrow that starts at 1 and goes to 2. So this point right here, I accidentally mixed up. Okay, this next point is 1, 2. And this last point, this 3, is connected with the 1. So now when I'm looking at my points, my x values, which are my inputs, I have 2, 1, 1, and 3. I have the same x value. Now, they can't go to different y values. So if I look at my outputs, this 1 goes to 1, this 1 goes to 2. That's not good. So that means it's not a function because this x value of 1 is paired with the 2 different y values. And those y values, or the outputs, are 1 and 2. Okay, the third way is by our graphs. Okay, so to determine if it's a function or not, I could list my ordered pairs like I've done in the past. Or, remember, I could use that vertical line test. So if I draw a vertical line through all my points, there's one vertical line. I can only have that one point on that one vertical line. If you notice, every single vertical line I draw has one point on it. And no matter where I put this vertical line, I could put one right here that doesn't have a point labeled per se, okay, but I know there's other points there, but no matter what, okay, each of those points is going to be on one vertical line. So this would be considered a function because of my vertical line test. Go ahead and pause the video and do this second graph by yourself. When you're done, push play. Looking at this second example, I notice that if I do my vertical line test again, every single one of these points falls on one vertical line. Therefore, this represents a function. And if I listed my ordered pairs, every single x value is going to be linked up with one y value. Okay, our last way that STAR is going to ask us how to identify a function or not from is our table. Okay, so looking at this table, I have my inputs, which remember are my x's, my outputs, which are my y's. And I need to see if it forms a function or not. So I'm looking for if all the x values have one y value. So the x value of 1 goes to 4, x value of 8 goes to the y value of 7, 4 goes to 10, 6 goes to 4. I notice that all the x values have that one y value, so this would be considered a function because all the x values have the one y value. Go ahead and do this, pause the video, and go ahead and do that second example from our table to identify if it's a function or not, and make sure you explain why and how you know. Okay, our last one. From this table, I notice my inputs are 3, 8, 3, and 9. Right away, I notice that this 3 is listed 2 times, and they go to the 4 and the 5 as their outputs. So this does not represent the definition of a function. These x values go to 2 different y's, which means this is not a function because the 3, which is our x value or our input, is paired with both the 4 and the 5 as its y value or output. Okay, that's all you have from me today. Remember that this TEK, you're going to have to identify if it's a function or not from ordered pairs tables, mapping diagrams, and graphs. So make sure you get it stuck in your head that the x values can only go to one y value. Okay, we'll practice more of this tomorrow. Have a great evening, and don't forget to go to the girls volleyball game today. It's our pink game, and wear your pink to support breast cancer in the fight. Thanks. Bye.